a web page. To go and say, file new project, hello world, and now let's talk about models and views and controllers and all this kind of stuff. This is a perfect entree, which gives you the full speed and the full power of C# and C# 7 and 7.1 because it is C#. It's not an addition to MVC. It is MVC because it's part of ASP.NET. All right, are you feeling good?
I'm feeling good.
All right, so let's switch over to you, sir.
Let's talk about speed.
Let's talk about where did
performance.
The clicky thing go? Clicky thing.
Yeah.
Click. Performance. That was all the value that I had right there.
Go ahead and click again. Let's talk about speed. So when we shipped ASP.NET Core 1.0, this was the fastest web stack that we've ever shipped with .NET. Like we benchmarked it in a public benchmark against all the other stacks pretty much on the planet, like in that benchmark. And the Tech Empower Round 13 plain text benchmark, we were in the top 10 for throughput numbers, like right up there with native stacks that are written in C++ or Go, right up at the top. Fastest stack we've ever shipped. On the cloud version, that was on physical hardware. On the cloud version, we're in the top 15. And ASP.NET Core 2.0 is even faster. Like these are the numbers that we're currently getting with the 2.0 bits. There have been performance improvements up and down the stack. Like we partner, of course, very closely with our friends on the .NET team. They've made improvements to the jitter, to the thread pool. We've done optimizations in Kestrel and up and down the stack, and we're now seeing about 25% throughput improvement with on these numbers are for the cloud. Based Tech Empower benchmark, literally the same benchmark.
And you can go and look at the benchmarks if you go to github.com/ASP.NET. There's a benchmarks section. It's all open source. It's all done in the open. You can run those yourself if it makes you happy.
But it's not just about throughput. Like we know, throughput is not the only perf number that we care about. Startup is also something that is important for people. How fast can the app start up? So I have two apps here. This is the startup app written in 1.1 and the startup app written in 2.0. Let me show you what these apps do. They're really simple. They're just the default MVC template for both versions, and then in their program CS file, they wait for the host to start. At the first line of code in the app, it starts a stopwatch, and then it waits to see how long does it take to make an HTTP request to the page, get the HTML back, and then stop the stopwatch. So it's a measurement of the startup time. But the 2.0 app looks exactly the same. It's just using the 2.0 model for actually setting up the host. But otherwise, it's just making an HTTP request to the MVC view.
This is important, because speed isn't just about how much HTTP you can pump out on the wire.
OK, so let's go to the 1.1 version, and let's do .NET, and let's run the, I have the published version of the app.
So ordinarily, you can say .NET run. That compiles it and runs it. He is going to go in .NET on the DLL.
So I've already done a .NET publish to build the DLL and do all the publishing gestures. And that took a long time. It was like 7 seconds. That was cold. If we let it warm up a little bit, we're getting down to 3 seconds.
3 seconds. That's OK.
3 seconds. Let's see.
On a laptop. It's not a Surface Book.
Yeah, we're going up. So we're about 3.5 seconds on my little laptop machine. Let's now look at what we get.
That was 1.1.
That was 1.1. Okay. Let's go to 2.0. So .NET, and again, I have the published version.
Also a nice example here where he's using that .NET driver at the command line. He's just typing .NET. He doesn't have to remember 50 different things. He just uses .NET.
3/4 of a
wow.
second.
OK, so that already did it. I thought I would be able to talk while it was starting up.
No, it's already up. It's
already going.
So how did we do this? We've done a couple of things. We have a runtime store now that ships with .NET Core that includes all of ASP.NET Core in it. That runtime store has already been cross-gen, so the JIT
cross-gen.
Cross-gen.
What does that mean? That sounds important.
That's the more flexible version of like enginning assembly, doing the translation from the IL to the actual native.
So they're native. They're native now. It's that moment when your Windows machine decides it's time to start native generating. It's done already.
Most of that work has already been done. That's one thing. And then we also on Publish we've enabled view pre-compilation by default. So all the views in the app have been pre-compiled into an assembly. They don't have to be compiled on the fly, which of course takes a bunch of time on startup.
Nice. From 7 seconds to less than a second. Nice.
The other thing that's interesting is the size of these published apps. If we go and look at the output of that published folder, this is the 1.1 version on your left. And you can see I have all the ASP.NET Core 1.1 assemblies sitting with the app. In 2.0, you don't need all of that because it's already part of the runtime. So all you have is your app assembly, and then there's the precompiled views folder. That's all you get. If we compare the size, this guy is what, like, I don't know, 14, 16 megs of stuff. The 2.0 version is going to be just under
3
3
megs.
megs. So much smaller deploy times as well. So that's a big
Nice.
thing. Clicky click,
What do you want? Oh, click.
click click. Azure. We talk about Azure.
Okay, cool.
All right, so we've done a lot of work in the framework to make it better, fun, easier to get started, make it faster, make it stronger. But we also think that there's a really compelling story to be told that if you combine, use that framework with services, you can get a really seamless and great story. And so we've tried to make ASP.NET Core even better when you use it with cloud services. So a couple things. For example, diagnostics and telemetry.
Right.
You saw this in Hunter's demo earlier today. That you can now take an ASP.NET Core app. I've got one here. I'll just
You drop it into the cloud and it lights up. You don't have to add a bunch of extensions. You don't have to add a bunch of NuGet packages. It just simply knows that it's in the cloud, and then it gives you the diagnostics that you want.
I mean, it's actually even better than that. Like what we do in ASP.NET Core is we have this host light up feature where the environment can inject services into the app for you and give value add services for your app just by virtue of running in that environment. So not only can you get those services in Azure, like we've done the work to light up like App Insights in Azure if you've checked the checkbox that you want it, but you can also do it within VS. Like I have this simple little app here. This is a
Fancy Pants?
Fancy Pants app. This is an app that just downloads a bunch of really cool images from Curiosity from NASA. Let's take a look at it. It's just mostly just going to be a bunch of images. Let's see.
Space images, which makes it better.
Of Mars. Oh, look at this. This is cool. This is like NASA is just.
Yeah, NASA
they
is the
do
bomb.
really cool stuff. I want to get some.
Cool.
Get some color ones.
Okay, so you're on the local host and you're going and getting that stuff. So I got a bunch of cool
There's
images.
the It's randomly just pulling down different sols, different days on NASA and pulling down the images. So it's making an outbound HTTP request, and I'm running it. Did I F5? I think I did Control F5.
Yeah.
Let me actually run it in the debugger now. When I run it in the debugger within VS, VS also uses host light up to wire up all the App Insights goodness within Visual Studio. So no change to my code. Like if we look at Fancy Pants, there's nothing in the program CS file that says App Insights anything. There's nothing in my startup CS file that says App Insights anything. There's nothing in my views.
Yep.
It just gets injected for me. So it's up and running now. Now if we look at the diagnostics tools, for example, for starters, you can see all these App Insights events are firing off. Like I can see like requests being executed, tag helper components. Make it bigger. Is that?
Yes,
And then maybe like do that thing that you say to do. Yeah.
There you go.
There you go. So I can see like the GET request. I can view details. That's sort of a summary view in the diagnostics page. If I hop out of this and then click the App Insights button, then you get this really cool search interface where if we filter down, let's look at just the requests. Let me run that, and you see there's my GET request. I can drill in over here and track the operation, and I get like a breakdown. See how it's like showing me every step of what's happening over the process of that request? That's pretty cool. If I unfilter, you'll notice that it's picking up dependencies for you. If I click those guys, you can see it knows about the outbound requests that I'm making to NASA.
Yeah, zoom in on that. It noticed that he's leaving his application. He's making an external call. This is the thing that makes that application insights map that gives you the sense of when your application talks to SQL or talks to NoSQL or talks to an external place. And then in the old days, we had to go and say debug.writeLine, got here, got here, got here. It's doing that.
It's doing that.
In the cloud for us completely, and then tells you how many milliseconds it took, and you can go and query it.
We're actually using the logging infrastructure of ASP.NET Core to do this, so you can see all the categories of ASP.NET Core.
Without you having to do anything.
You can filter them, and it's all this. So that's something you can use during development, just like you can use the stuff that Scott showed in production in Azure.
And this can be put in a local-only mode. Nothing is sent to the cloud. You have absolute control over what is being sent around. So to be clear, you can go and say, enable App Insights, SDK, local only, and nothing gets sent to the cloud, and you still get that great experience.
So this is the cloud version of this application. It's deployed to an Azure App Service. You can see that the address now is like fancypants@azurewebsites.net. If we go to the portal and look at that actual app service, you'll see the light up experience that you get. Like this is the app service. In a second, there'll be a bar that pops up at the top and says, hey, would you like some Azure App Insights for your ASP.NET Core application? We know it's an ASP.NET Core application. We know how to hook into that. That sounds good. I've already done that for this application, and so we already get all that data that you saw previously with the application map and all the logging and telemetry. But the thing I wanted to show you is how this is actually working, because this just blows my mind. Like this is the app, right? F12 and go into
You're
the
like
DOM
way too
Explorer,
geeked about this feature.
This is amazing. Like, I was like, how are you going to do this part? Like, if you look in the head of the app deployed to Azure, there's nothing changed in the code on my side, but there is the JavaScript being injected somehow for App Insights.
And that little bit of JavaScript lets you catch all of those client-side dependencies. So when you have an Ajax app or an Angular app that's doing things client-side, we'll go and grab that. So you can get an experience of the timeline from the moment your page loads all the way until it hits a database or a backend web service. Without you having to do anything.
The way that works, I actually asked, went to how did you do that? And the way they do it is there are head and body tag helpers for those parts of the pages. And those tag helpers know how to append content to the page based off of services that have been added through DI, through dependency injection. So all App Insights has to do is add their services into the